Okay, continuing with our lesson on applications involving rational equations. I don't know why the video cut out on me partway through this problem, but here it is. Pause the video if you need to get the rest of this down. We're going to set this up very similarly to the other problem. So we're going to have a percentage for David, and we're going to have, not a percentage so much as a fraction, right? A portion of the job that they did. Working together, they're going to finish one complete job. So what do we know? Well, this time we have information, we have clearer information about what goes on the top of the fraction than on the bottom of the fraction. What we know is that working together, they can roof a house in 4 days. So the amount of time that each individual did in fact work is 4. So the question is, what goes in the denominator of each one of these fractions? How long does it take them working alone? And that's what we're looking for. We don't know that for sure. What we do know is that Terry can work 3 times faster than David, because David's just learning. Terry's been doing this for years and years. This is representing David. This is representing Terry. And here's where there's a little bit of a twist. It can be tricky to know where to put the 3 times, right? So we're going to want somebody working for a certain amount of time and somebody else who takes 3 times as long. And since it says Terry can put a roof on the house 3 times faster than David, you might think that the 3 times might have to go with Terry because he's 3 times faster. But think about it. If you plug in 2 days here and 2 days here, isn't this person working 2 days and that person is working 6 days? David is the one who's slower. It takes him 3 times as long. And that's kind of tricky. People get very confused about this, so be careful with this. You're going to multiply the amount of time that it takes Terry by 3 to get the amount of time that it takes David, because David takes longer. He is slower. At least he was back in the day. So, again, we find an LCD. We multiply both sides by that LCD, and we solve the problem. Distributing here, when you multiply this by the first term, the 3 t's cancel, and we get 4. Multiplying by the second term, just the t's cancel out, and I get 3 times 4, which is 12. That's equal to 3t, and now we just have a linear equation. We need to get the t by itself. 4 plus 12 is 16. Divide both sides by 3, and we get that the amount of time is equal to 16/3. But you know, what is that really? And by the way, have we answered the question? How long would it take each of them working alone? So we need an answer that says Terry takes this long and David takes this long. I want to simplify this a little bit. Our units are days. 3 goes into 16 5 times with 1 left over. That's 5 1/3 days. T is the amount of time it takes Terry, working all by himself, to do the whole job. So Terry can do this in 5 1/3 days, but David, who takes 3 times as long, well, that's easy enough to find. If I multiply this by 3, it's the same as multiplying this by 3, which would just cancel the 3 out. 3 times 5 1/3 days would be 16 days. Wow, that must be a really big house. Okay. We are going to do one other work problem, because sometimes there can be a little twist. Sometimes maybe you don't want to do a whole job. Maybe you're filling a swimming pool and you only want to fill it halfway. Sometimes you're not working together, sometimes you're working against each other. My first problem in the previous video, I could have said, how long does it take for the room to get totally clean or totally messy? If I'm in the room cleaning it, well, one of my sons is in the room messing it up. Well, if you have two things working against each other, instead of adding here, you're going to subtract. Again, if you still need to get this information down, pause as long as you need to, and then hit play when you're ready to move on. So here's our final problem, and it does have to do with a swimming pool. So somebody made a mistake, they're trying to fill it, but they left the outlet pipe or the drain open at the same time as they're filling it. So an inlet pipe can completely fill a swimming pool in 9 hours. And an outlet pipe, in other words, a drain, can empty the pool in 12 hours. So somebody made a mistake and left both pipes open. So I'm just going to say if both pipes are open, one filling, one draining, how long will it take to fill the pool halfway to the top? So we're actually only doing half of a job. We're not filling the whole pool. So up here, the thing can empty the pool, the whole pool. This one can fill a swimming pool, but we're asking about halfway. So when we add the fraction, or when we combine, I shouldn't say add, inlet and outlet both working, we want the job that's accomplished to be 1/2 of the full job of filling the pool. But because the outlet is draining while the inlet is filling, these are doing the opposite actions, and so we're going to subtract rather than adding. They're not combining their work, they're working against each other. So we're going to have a fraction for each with a minus sign in the middle. The inlet can fill the pool in 9 hours all by itself. Since that's the amount of time it takes to do a whole job all by itself, the 9 goes on the bottom. The outlet pipe can empty the pool. It can do its whole job all by itself in 12 hours. And again, the minus takes care of the fact that their jobs are exact opposites, one filling, one emptying. The question is, how long will it take them to fill the pool halfway to the top? They have both been left open, and they're left open for the same amount of time. So I'm just going to say T for time, and then we go about solving this rational equation. Rational because it involves fractions. We want to cancel out the 9, the 12, and the 2. And an LCD of 36 will do that for us nicely. Put a 1 on the bottom if it helps. Distribute through over here. 36 times t over 9, well, we could cancel with the 9 and the 36 and get a 4 up here. So this is going to be 4t. Then multiplying by the next term, 12 goes into 36 3 times. So we get 3t. Over here, we just have straight up fractions, no variables in there at all. 2 goes into 36 18 times. 4t minus 3t is equal to 18. So that's just 1t, or just t. That's 18. Well, what does that mean? Let's come back over here and look at our units. We are talking about hours in each case. And they're asking us, how long will it take to fill the pool halfway? So this is hours. So we could say in 18 hours, the pool will be half full. Hopefully at that point somebody notices that they accidentally left the drain open and they will close that pipe. So we could ask all sorts of other questions related to this. If somebody closes the pipe after 18 hours, how much longer will it take the inlet pipe to fill the pool? We could have asked a question such as, if the drain had only been open half of the time, then how long would it take for the pool to fill all the way or part of the way? So all of those take little tweaks to what you've got. But hopefully the tweaks make sense, right? If you have two items working against each other, we have minus instead of plus. If you want half of a job to be done, then you use a 1/2 instead of a 1. We saw in the last problem, if someone can do a job 3 times faster, well, one of the people completes the task in 3 times your variable, 3t, and the other person can complete it in just the time of the variable, just t. So these problems can be changed a little bit, but the basic idea is what percent or what fraction of the job did one object or individual do? What fraction of the job did the other object or individual do? And then that's going to be equal, usually to 1. But maybe you want to do half of the job sometimes. So I hope this helps you as you do your work with applications involving rational equations.